Alright, here we go. A little video on what's known as complex numbers. And we're also going to work with some imaginary numbers today as well. Now, imaginary numbers are something that's probably a little bit new to you. Basically, it means that we can now take the square root of negative numbers. So we know that the square root of 25 is 5. That hasn't changed. But the new thing is that the square root of a negative 25 is now possible. The answer is 5i. So before we even get started, when you see a negative square root now, you can take it. Just make sure that if it's a negative, you finish your answer with an I. So the square root of a negative 9, the square root of 9 is 3i, because the square root of a negative 1 is I. The square root of a negative 12, you still factor it, break it down however you want, and simplify it. So the square root of 12 is 2 root 3. So now we just write 2i root 3. So remember, you want your I before any radicals, but it comes after a number if it's attached to it. Okay? And 15 cannot be simplified. So since it's negative, the square root of a negative 1 is I, and square root of 15 cannot be simplified. So it's I root 15. So those are imaginary numbers. Complex numbers is when you have a real and an imaginary number that are combined, either added or subtracted to one another. So there's a lot of different things we can do with complex numbers. So the purpose of these problems are just to show you how to work with them. After this video, working with complex numbers is going to be a skill, and we're actually going to solve equations and do all sorts of other things with complex numbers. So first thing we're going to do is talk about adding and subtracting. When you add and subtract, it's just like combining like terms. So we have 3, 2i, a 7, and a 6i, so we can combine our real numbers. 3 plus 7 is 10. And then we can combine our imaginary numbers. 2i and 6i add up to 8i, and we're good. So why don't you try the subtraction one? Alright, you should have negative 3 plus 3i. Remember, when you're subtracting, you might want to change it to a plus, make that negative, and make that plus. So 3 minus 6 was a negative 3, and a negative 4 plus 7 is a positive 3i. Okay? When it comes to multiplying, you multiply just like you would FOIL anything else. But there's a little trick. So 3 times 2 is 6. 3 times a negative 3 is a negative 9i. 2i times 2 is a 4i. And a 2i times a negative 3i is a negative 6i squared. So hold that thought for a second. Combine like terms, we have 6 minus 5i minus 6i squared. So now we need to think for a second. Remember how we said that the square root of a negative 1 is I? Earlier we were talking about that. Square root of a negative 1 equals I. That means I squared is equal to a negative 1. Special note. So in this problem right here, this is actually a negative 1. So we can rewrite this as 6 minus 5i minus 6 times a negative 1, which turns that into plus 6. So 6 plus 6 is 12 minus 5i. Okay, you guessed it. You get to try the next one. Multiply 6 plus 2i times 6 minus 2i. Go do it. Did you get 40? Because if you did, you are correct. Notice how we have a 6 plus 2i and a 6 minus 2i, so everything's the same, but we have a positive and a negative. That's going to make these i's in the middle cancel. So whenever you have that, you're going to end up with just a number, as long as those are the exact same a and b. Just one is a positive bi and one of them is a negative bi. Last skill you need to know how to do with i's, and that's divide. Now, there's kind of a rule with i's, just like radicals. You're not allowed to have them in the denominator. So to get rid of it, remember that skill that we just talked about a few seconds ago? He's written in red and he ended up being 40. If you want to multiply to get rid of something in the denominator, you need to make the I go away. So you're going to have to multiply the top and bottom by something. And that something needs to be what is known as the conjugate. And that's what we just did up in red. So this is going to end up being 4 minus 3i. Now we multiply the top and bottom by 4 minus 3i. Okay, it's like multiplying by 1. But just like you saw up in the red one, since we have a 4 plus 3i and a 4 minus 3i, the i's are going to cancel in the middle when you combine your like terms. So what you do is you're going to FOIL the top, just like you normally would. So 3 times 4 is 12. 3 times a negative 3i is a negative 9i. 2i times 4 is an 8i. And a 2i times a negative 3i is a negative 6i squared. Okay, and then obviously you can simplify the top. And then the bottom, you're going to do your 4 times 4, which is 16. You're going to have your 4 times a negative 3i, which is a negative 12i. 3i times 4 is a positive 12i, and there they go again. They're going to cancel, so now you don't have to worry about an I in the denominator. And then 3i times a negative 3i is a negative 9i squared. So the top over here, we have a negative 9i and a positive 8i, so that's going to leave us with a minus I. And then we're going to have our 12, and then we have a negative 6, and this is a negative 1, so this is actually a positive 6, so this is 18 minus I all over. And then we have 16, and this is going to end up turning into plus 9, so we have 25. Okay, that's that. So guess what? You guessed it. You get to do the last one on your own. Go for it. So if you got 6 minus 2i over 2, you are kind of correct. Now I wanted to stop here for the moment just so I can continue it with you. Whenever you have something like this that can be reduced, you need to reduce it. So there's 2 ways you can do it. One of them is to just think about what you can divide out of here, but the better way to do it is to rewrite it. So we write the first, so we have 6 over 2, and then we have our minus, and now we write this, which is 2i over 2. Okay, it's just splitting this into, 2 fractions. So then we are in a 6 divided by 2 is 3. 2 divided by 2 is 1. So your final answer is actually 3 minus I. That is the conclusion of this complex number video. Again, the purpose of this video is to give you the skills you will need to be able to work with radicals, imaginary numbers, because we are going to take this to the level of being able to solve for x and all sorts of other things. Okay? So, this is Longo, and I am out. See you, bye, and have a good day.